Here's our first problem. Number 1 says, which is the better buy? You can get a half pint for 90 cents, 1 pint for $1.65, 2 pints for $3.40, and 5 pints for $8.10. Because each one of these is a different amount of pints, we can't compare the amount of money spent for each one unless we switch them all to the same amount of pints. Now, as you can see right here, this is already 1 pint. So we're going to switch everything to 1 pint to make it easier to look at. So it'll be the amount of dollars per pint. So we're going to start with a half pint. It's the most frustrating one on here because it's a fraction, but it's definitely something that we can handle. So I'm going to draw a ratio table. Because it's the amount I'm paying per pint, I'm going to do money on top and pints on the bottom. So I'm going to fill it out with what I have so far. I know it's 90 cents for half of a pint. I can solve this a couple different ways. I could switch it over to a decimal, and then I could just divide. Or I could think about the fact that it really is just a half pint. And if I'm trying to get to 1 pint, I know there's 2 halves in 1. So if I double my amount on the bottom, I can double the amount on the top. So it'll be $1.80. So that's $1.80 per pint. This one's $1.65 per pint. Okay, let's keep going. The next one is 2 pints for $3.40. So it's still money, still pints. This time it's $3.40, and that's 2 pints. Again, because I'm talking about unit price, I'm looking for 1 pint, the amount for 1 pint, the amount per pint. So to get from 2 to 1, I'm simply dividing by 2. So I have the same thing on the top. $3.40 divided by 2. I can cut that in half really easily in my head. If I couldn't, I could draw it out if I needed to. But that's just going to be $1.70. So that's $1.70 per pint. And then I have to do the last one, which says 5 pints for $8.10. Again, it's money and pints. $8.10. 5 pints. I'm trying to get to 1. Now, I know going to 1 is my goal, but dividing by 5 is not as easy as I'd like. And if I want to be able to do this without a calculator, I could just add an extra step in. I know that if I double my 5, I'll get 10. So that would be $16.20. And I can simply use my shifting strategy that I learned a couple units ago. And I could say, okay, so if I'm doing $16.20 and I'm dividing by 10, that's the same thing as shifting everything one place value. So 16.20, draw my little lines. If everything is being divided by 10, everything is going down a place value. So the 1 that's in the tens place goes to the ones place. The 6 that's in the ones place goes to the tenths place. The 2 that's in the tenths place goes to the hundredths place. So $16.20 divided by 10 is simply $1.62. Now keep in mind, this was a little more work because I was doing it without a calculator. If this were a calculator problem, which sometimes it will be, doing $8.10 divided by 5 will give me the exact same answer. So keep that in mind. Sometimes a calculator is allowed, sometimes it's not. You have to be ready for any given situation. Now for this problem, because we're talking about price, we want to make sure that we are getting the best deal we can. We don't want to pay more money than necessary for each pint. We want the lowest amount per pint, which in this case is going to be the 5 pints for $8.10, because that's the smallest amount. So this is the better buy. This problem is very similar. Again, we're looking for better by. The only thing that really is different is last time it was pints the entire time. This time we're switching between grams and kilograms. So the only thing you really need to know here is that kilogram, notice how I said that. See how that says kilo? Kilo means 1,000. So kilogram is going to be 1,000 grams. So if I'm given grams and I want to switch it to kilograms, or the other way around, I just have to switch up the problem a little bit. So if I want to go from grams to kilograms, grams divided by 1,000 will give me kilograms. Kilograms times 1,000 will give me grams. This is really similar to our last unit where we had cubic centimeters and there were 1,000 of those in a liter, so I could switch back and forth between the two. This is very similar to that. So all I would do is I'm going to switch each thing. So if I have 250 grams, and I want to know how many kilograms that is, well, if I know that there's 1,000 grams in each kilogram, I could simply divide by 1,000. So 250 divided by 1,000. Notice how I wrote that as a fraction bar. Division is nothing more than a fraction bar. So 250 divided by 1,000, that's the same thing as a quarter, or 0.25. You could decide if you want to use fractions or decimals depending on the situation. If you have a calculator, decimals are probably better. If you don't have a calculator, fractions are probably better. So we're going to replace that with a quarter. 500 is very similar. So 500 divided by 1,000, that's the same thing as half or 0.5. I'll stick with a half. So from here, the problem really is straightforward. There's not really too much to do. All I'm going to do in the case of a quarter is to get from a quarter to 1, I'm going to multiply by 4. So $1.85 times 4. That one I might need a calculator for, or I could do that in my head. Turns out that it ends up being $7.40 per kilogram. Notice how I used the slash. That's one way to say per. So $7.40 per kilogram. This other one, the half of a kilogram, I'm going to have to double that to get to 1. So times 2 gives me $6.10 per kilogram. This one's already in kilograms, so that's $5.90 per kilogram. And the last one, because I'm going from 2 kilograms to 1, we're going to divide by 2. So $12 divided by 2 becomes $6 per kilogram. Again, we're looking for the better by. We want the number that's the smallest. So the 1 kilogram for $5.90, that's the better by. Okay. So when I'm dealing with unit rate, it's very similar to unit price. Same basic idea, except I'm no longer dealing with money, and I'm not always looking for the smallest amount. So for looking at miles and gallons, for instance, when I'm talking about gas mileage, that is where I'm looking for miles per gallon. They always write it as MPG, but that simply means, again, miles per gallon. You're still using that per. So I set up my ratio tables, miles, and then gallons. And then all I have to do is put my numbers in. 60 miles, 3 gallons. If that had said 3 gallons and then 60 miles, the order doesn't matter, but make sure that you set up your ratio table appropriately. So make sure the right numbers go with the right letters or words. And we're looking for miles per gallon, so notice how I put the gallons on the bottom. Whatever is after the per goes on the bottom. So 60 miles, 3 gallons. I want to get to 1 gallon. That's my goal. So I'm simply dividing by 3 on the bottom. So I'm dividing by 3 on the top. 60 divided by 3 is 20. That's clearly a not calculator problem. And that's 20 mpg, 20 miles per gallon. For the next problem, I still have miles, I still have gallons, but this time it's 50 miles and 2 gallons. So I divide by 2, and I get 25 miles per gallon. Now with the last problem, I wanted my number to be the smallest because I was looking for the best price. In this case, I'm looking for the best gas mileage. With gas mileage, you actually want the number to be bigger because you want to go further on 1 gallon. So 20 miles per gallon says I can go 20 miles for every 1 gallon. But 25 miles per gallon, I can go 25 miles for every 1 gallon. That's actually better. I want to go further for each gallon. So it turns out that 25 mpg, which came from the 50 miles on 2 gallons, is the best choice. So for most problems when we're dealing with unit price or unit rate, you're simply dividing. If you set it up as a ratio table, it's really easy to tell which way to divide. Again, whatever word comes after the per should be on the bottom of the ratio table. The word that goes before the per goes on the top of the ratio table. It's an easy way to set it up to solve problems like this in the future. Good luck on your own problems.